AI is everywhere in business these days, and with rapid innovations, continuously adding new models and new techniques to what I'm going to conceptualize here is our AI toolbox, it's important that we also continually adapt how and when we use what out of that toolbox and in a very dynamic way. Today, I want to talk through a new approach using an ensemble of AI models that will help get you more value out of that growing toolbox. So let's go through 3 things. Let's dive in to that toolbox and understand our tools a little bit better. We'll set ourselves a framework. Second, let's talk about their different attributes, their characteristics, so that we can understand their strengths and therefore when we might use what. And then lastly, we'll overlay all of that with some examples, with some use cases. So let's take a look at our first tool. Up until now, a lot of the development and the use cases has been around traditional AI. Traditional AI is built on machine learning and deep learning models. Another tool that we have are large language models, or LLMs. Large language models are largely built on encoder and decoder models, but we'll table that for now. Historically, a lot of the discussion has been on when to use traditional AI or when to use large language models. What this technique opens up is the and. It allows you to leverage multiple AI models to take advantage of their different strengths based on the situation to get you the most out of your data. So now that we have a framework of our tools, let's dive in a little further and let's talk about their different attributes. So traditional AI, at a very simplistic view, how does traditional AI work? It looks at structured data and then following a set of rules, it makes a prediction. And along with that prediction, it gives you a confidence rating. The types of models that you would see that on, there's a couple in the financial industry. You'll see fraud analysis done, anti-money laundering, insurance claim analysis, and medical image analysis. Those strengths that I mentioned earlier, for traditional AI, they tend to be smaller in size. They tend to have lower latency, so they're faster. And they tend to use less power, so they're more energy efficient. Let's jump over to our large language models. Starting with the encoder models, let's talk through 2 spaces here. The first space, they work similar to traditional AI. They start with structured data, they follow a set of rules, they make a prediction, and they give a confidence rating. But because those encoder models use a different set of techniques, and they also use larger, more complex models, they also tend to have a little bit higher power. They're less energy efficient, a little higher latency, so they're a little slower. If you look at that list, why would you ever use those models? They're more accurate. Their accuracy is increased. Where might you see those? Like I said, similar case, fraud, anti-money laundering, insurance analysis, and image analysis. I mentioned a second type of encoder models. So a separate space there, instead of starting with the structured data, they actually convert unstructured data into structured data. And I'll give an example later to bring that home a little bit more. Decoder models, they also start with unstructured data, but they actually then generate new data. These are chatbots, for example. And again, that's a big space there. So you can start to see, as you look at the different characteristics, the different strengths of these models, that dependent on the situation, you may want to use a different model type. So this technique, what that allows you to do is live in this hybrid world where you can have multiple models. And then based on the situation, based on what strengths you want to leverage, so maybe accuracy or sustainability, speed, size, you can in a very dynamic way switch between those models, giving you the most accurate prediction in the least amount of time. So examples, like I said, now that we have this framework, let's overlay some use cases on there. So let's start in the financial industry. Let's zoom into fraud analysis for a minute, because credit card fraud is unfortunately very relatable to a lot of us. And you can also understand that in that situation, you want the highest accuracy, but in the least amount of time. How do you get those two different strengths on two different models? Again, the power of this approach. So you go to the store, you swipe your credit card, and because that financial transaction is probably already running through a mainframe, you can use the powerful AI capabilities that mainframes have to extract some data while that transaction is already taking place. So you can run it through a traditional model and you can get a prediction with a confidence rating whether that transaction was fraudulent or not. Most of the time, you'll have a high confidence and you move on. Periodically, if you have a lower confidence, you can switch over to that large language model where you get the accuracy that you need. So you can see that approach on a mainframe maintains the speed and the sustainability of the smaller models while leveraging the larger models for accuracy when you need it. I'll close by doing one short additional example where we showcase the reverse of those two. So let's look at insurance claim analysis. Insurance claims are a mix of structured and unstructured data. Structured, your name, your geographic location, a dollar amount, and then unstructured, a bunch of text about that particular incident. So you'll start over with a large language model. You'll run it through the unstructured to structured, so you get more data to then run through and do that analysis. You may jump straight to a large language model to get the accuracy that you need, or similar to the last example, you first run it through a traditional AI model, get your prediction and your confidence, and then only then, if needed, switch over. So hopefully you can start to see with these two examples the power of these multi-model AI environments and the value that you can get out of this technique.